Alright, so folks, this is the May 2024 AdMaths Paper 1. Right, so just gonna see how quickly I can go through this multiple choice as I have a bit of a time limit. And just a disclaimer, I'm a little rusty as I had an assistant this year who actually kind of took over my AdMaths class. And normally I'd be, up to speed and well sharpened and practiced in these things. But that's not the case this year. So I was taking a look through the paper, and I wouldn't say concerned, but there were some questions that seemed a little out there to me. But you know what? That is just part of the fun. Sometimes it's nice to have a challenge and to show you guys how we as teachers work through the challenge. Right? There's actually a question that my friend, who actually has a math degree and has taught math and pure math for 25 years plus, told me he had no solution. But I think there is one. I would always usually kind of defer to his wisdom in these cases, but anyhow. So guys, it's 1:15 and I'm going to start. So let's take a look at question 1. Now, just by the way, my official opinion is that a multiple choice paper for AdMaths makes no sense. Right? Because the amount of work you have to do for most of these questions, you might as well get some marks for it, right? There are some things you can test AdMath-wise. A multiple choice question, AdMath, fine. There are some things, but it should not form part of your assessment. That's just my opinion, right? I have no PhD in my name, so clearly it doesn't count for much. Anyhow, so the expression x minus 3 is a factor. So clearly we're using factor theorem. So what do we do in this case? Because on top of that, where are we supposed to put the work in on the paper? Well, some of these workings are quite involved. All right, so let's just take a little quick start. Right, so what we're going to do, we're going to let that divisor x minus 3 equal to 0, which then gives us that x is equal to 3. And then what we have to do is substitute x equal to 3 in each of these things here to see which of them simplify to 0. And that's how we know which of these expressions x minus 3 is a factor of. Now I can tell you right off the bat, b is out, and I'll tell you why. If you were to sub 3 inside of that, you only have positive terms, right? Taj, that's correct. Yeah, you're quite right. Yeah, so you only have positive terms, so it's not going to cancel to 0, right? In item A, we can do some quick maths there, right? 3 to the 4th power is 81. 81 by 3 is 243, and 3 squared is already 9, right? You're minusing 51 from 243, so that's not going to be equal to 0, so that is also out as well. So really and truly, we only have 2 items in the running, which are item C and item D. And I can tell already, item C is probably going to be, because look at that. You have x cubed, right? So you have 3 cubed, and you're subtracting 3 by x squared. But 3 by 3 squared is going to give us 3 cubed, and when you minus 3 cubed from itself, you get back 0. Okay, looks promising. Then you have 5 by 3, which is 15, and you add in 15. But it's a minus 15. So when you simplify here, you're going to get 0. So the answer here is item C. Okay? Right, so unless you work really quickly and really accurately, you probably won't have time to test out all of them. So you have to know some of the little tricks, right? Item 2 is one we see in quite a number of papers. So if you guys haven't done any more AdMath paper, was that? Live chat didn't okay, whatever. Right. Yeah, if you haven't done any other AdMath papers, you really need to, because the number of repeats is ridiculous, especially in the earlier part of the paper. In the later part, they started including probability and statistics, and we have an attempt at kinematics. So when we're adding fractions, ladies and gents, what do we need? A common denominator. Now here, what we can do to kind of make things a bit simpler is we are going to express x squared minus 9 as the product of its 2 factors. And x squared minus 9 is clearly the difference of 2 squares. So our common multiple, our common denominator, will simply be x plus 3 by x minus 3. Right, so we're going to multiply the numerator 1 by the x minus 3, because the x plus 3 is common, and then the 3 is just going to come down. And then minus 3 plus 3 will cancel to 0, leaving us with x is the numerator, and your denominator is x squared minus 9. So that is option B. There you go. Oh wait, I should probably put this on. Yeah, let's go. Yeah, it is AdMath. It is AdMath. Alright. Yes. Sorry. The minimum value of the expression. So we can use a simple formula. So first of all, we'll use A, B, and C, right? The usual kind of quadratic fare, ax squared plus bx plus c, right? The minimum value of a quadratic is just given by k, and one of the versions of the calculation of k is 4ac minus b squared all over 4 by a. So you have 4 by 4 by minus 5 minus 8 then squared all over 4 by 4. Alright. Alright, so 4 by 4 is 16, 16 by minus 5 is minus 80. And you minus, so the square of minus 8 itself is 64, and that's all over 16, so we get minus 144 all over 16, and that's minus 9 as option A. Now you can use your calculators in this multiple choice as opposed to the regular math multiple choice. Anyhow, sorry, I forgot to erase this little piece. Okay, so they want to express this in the completed square format. Nobility, we're doing add maths now. Check back later around 5:30 for math, right? So every day this week, Monday, Tuesday, Wednesday, Thursday, obviously not Friday, because Friday's the exam. We're going to be doing a math multiple choice, a paper 1, from 6:30 to 8:30. Right? Last week we did May 2021, 2022, 23, and 24 from Thursday to Saturday. This week we're working on January papers. Alright? Okay, cool. So the value of a is the coefficient of the x squared, which here is just 1. So we could eliminate b. Alright, that's out. Okay, and then h. So h is simply equal to b over 2a. b is minus 6, and then you have 2 by a, which is 1. So you have minus 6 divided by 2, which is minus 3. And there's only one option here with a minus 3, and that's option A, right? So you see, sometimes you don't have to work out everything, you can work out certain things, and then that's sufficient for being able to solve the question. Alright, the roots of this equation are, so what they're asking you here is to use a discriminant to describe the nature of the roots. The discriminants are given in a label A, B, and C, right? So b squared minus 4ac. So b squared is minus 7, then squared multiplied by 4 by 3 by 3. Minus 7 squared is positive 49. 3 by 3 is 9, 9 by 4 is 36, and 49 minus 36 rather. Right, my apologies, it's 13, which is positive. And when you have a positive value for the discriminant, you have real and distinct roots. Okay, this question here, when I looked at it, I think Saturday, it totally threw me the way it was phrased, and I got it wrong. So when I went back, I asked a friend, and when I went back and looked at it after, like, oh yeah. So what values of y simultaneously satisfy these equations? So basically what they're asking for, what are the values of y that are the solutions to this equation? So what we can do from this equation here, now you have, okay, you know what, let's just do it the usual way. We'll simply make y the subject by quote unquote carrying across the x by adding it to both sides. So we'll just have it as x plus 1. Now if y is equal to x plus 1 and y is also equal to this, it stands to reason that the quadratic, you could let the quadratic x squared minus 3x plus 4 equal to this x plus 1. And then we could subtract x plus 1 from both sides. Subtracting x, so you're going to minus x and minus 1, and you're going to get x squared minus 4x minus 3 equal to 0. So when you factor that out, you're going to get x minus, wait, sorry, did I do the right thing there? Because it's not, hold on, just now, this is what happened Saturday. I made a mistake with the sign, alright, it's a plus, okay. So that's minus 3, 4 minus 1 is plus 3, that's exactly what happened, Right, so be careful, so my mistake is piece of the lesson here. Alright, so we're going to get our x minus 1 by x minus 3. Now when you multiply two things and you get 0, or any number of things and you get 0, clearly one of the factors has to be 0. So if x minus 1 is equal to 0, x has to be 1. My quality, alright, give me 1 sec, let me see what's going on, right? When I say quality, you're talking about volume, defaulty. Right, you know what, here, let me open the controlling software, because I already have this turned up quite a bit. It has already at 9 o'clock position. Yeah, I don't know how much else to do. Let me see. Yeah, and that gain is up to 72. Yeah, if okay, so what I'm gonna leave this app open, right? So defaulty, if you're tagging along, Just let me know if the level, if the level drops, right? Level being the volume. Quality is, it's like breaking up and that kind of stuff. A is 8, 9, right? Okay, yeah, sorry, so x is equal to 1, and if x minus 3 is 0, it means x is 3. Now, we're going to use this, sorry, I did not say the whole thing, right? We're going to use this to solve for y, so therefore, right, y will be either equal to 1 plus 1, which is 2, or 3 plus 1, which is 4, right? So the option here is D. Okay, cool. Right. TikTok is better for some reason. Yeah, I don't know. I mean, I'm facing this way, and you guys are maybe thinking now, is it better now? Is it lower now? I wonder where the story is going. I don't know, maybe the chord. I was bending it a couple of ways. Maybe I created a short. Hey, look, Paige. Hello, Paige. Let's do some ad math. I didn't do any ad maths for the season, so I just consider me 2024 people on. Right, the values of x for which 3x minus 2 and 2x plus 1 are less than equal. Okay, so what we do is we multiply. Whoa. Yeah, sorry. Yeah, we're gonna multiply. No. Right, okay, cool. Yeah. We're gonna multiply by 2x plus 1 then squared. Right, so what that does is it basically creates like a factored quadratic. Right, 2x plus 1. Or less than equal to 0. Okay, so that means negative. Right, now what we do is we let each of these equal to 0 just to find the value of x that we want to start with. Right, so 0, so in this case you're going to carry over the 2 then divide by 3. Right, and then the next one you have 2x plus 1 equal to 0, in which case x is equal to minus a half. Right, so what I do with the quadratics regularly is I would then create like a little mini coordinate axes, right? The Cartesian plane, right? So minus a half and then 1 and minus 2, right? So minus a half would be a little nearer, right? So that's a minus a half there. That's a 2. Okay, so the diagram not drawn to scale, right? Now they want, what do they want? They want where it's negative. Okay, so negative values lie beneath the x-axis, negative values of y. So we're between the roots, right? So the answer here would be that you have your minus a half on that side, your x here, and your 2/3 here, right? Now the thing is, you can have it less than equal to 2/3, but you cannot have it greater than equal to minus a half, because if x was equal to minus a half, well, what happened is, right, Ricardo, really? Yeah, because I have a 4 o'clock, I have a 4 to 6 maths, and I have, 4 to 6, yeah, a lower school math class, and I have my 4 and 5 for maths after the 6:30 to 8:30, yeah, so if I didn't do it, no, I wasn't doing it at all. Shy, 6:30. Oh, wow, okay. Just now, I have to answer my wife real quick. Sorry, so the answer here clearly, yeah, sorry, I was saying that if you let this equal to minus a half, the value of the denominator will be equal to 0, and then you have an undefined fraction. So you don't want to have that being undefined, right? Right, hey, so the order's a bit low. Aditya, how are you doing? Okay, 1 second. I don't want it to be too high, because then you get like a kind of, on the replay is some kind of overbearing, a little staticky, right? Okay. The set of values of x for which 3x squared plus 5x is greater than 2. So what we do here, oops, sorry, I forgot to change back to the other point. Right, so we do 3x squared plus 5x, and then you minus 2 to bring it on everything on one side, right? Also, Aditya, you said YouTube, okay. Yes, 6 to 9, that's correct. Okay, right. So let me just take that off real quick. Right, so what we do, we're going to factor as per usual, right? So you're going to have 3x, x, right? And then we're going to put the 2 here, 1 here, put a minus and a plus, right? So another shortcut factorization for you all. Okay, so again, we're going to let the 3x minus 1 equal to 0, in which case x is a third, and then we also let x plus 2 equal to 0, in which case x is equal to minus 2. So again, we're going to do a little Cartesian plane. Alright, oops, sorry, I don't know how we turn into an arrow, but alright. Right, so minus 2, again, not drawn to scale, so minus 2, and then you want to there, that's your origin, that's your y-axis, that's your x-axis, right, and then you have minus 2 down here as well. Okay, now they want it greater than 0. Greater than 0 means positive. Positive values of the function lie above the x-axis, right, so you have x is less than equal to 2, sorry, x is just less than, not less than equal to, right, so x is less than minus 2, as well as x being, x is greater than, x is less than minus 2. You know, I said the right thing, but I wrote the incorrect thing. And x is greater than 1/3, right? So that's option D. Okay, cool, right. Eliana, it will. It's being live there as well, and as soon as I'm finished, it's going to be posted. Alright guys, so that's page 1. I'm just going to zoom out real quick. Alright, oops. So you hopefully see the whole page. And all the solutions? Okay, cool. Next page. Yeah. So 50 minutes gone already, boy. Wow. Alright, yeah. So moving a little slow. Yeah, well, maths is you have to sometimes. Okay, 4 over root 6 minus 2. Okay, so they want us to clearly, what you call it, rationalize the function, the denominator. So we're going to multiply by what we call the conjugate of the denominator. And the conjugate is that factor which when multiplied by the original will cause it to become difference of 2 squares. The BN, yes, math, that is correct. So the numerator will be 4 by root 6 plus d, all divided by 6 minus 2 squared, which is 4. Because it's root 6 by root 6, which will give us 6, and minus 2 by plus 2 is minus 4. So that itself is 2. So what we're going to have a 4 root 6, 4 by root 6 plus 2, all over 2, and then 2 will cancel with the 4, the coefficient of the numerator, giving us just 2 by root 6 plus 2. That's option B. This next one here, right, so that's an n in front of that, so this is actually the nth, that doesn't look much better, right, the nth root of 3 by 27 to the m. That I'm looking real bad. Okay, that's not much better. Okay, that's where my time goes. Rewriting stuff. Okay, so what we're going to do, let's put that 3 to the power 1. 27 is 3 cubed, so 27 to the m is 3 by 3, 3 to the power of 3m. And then we put that as a rational index, right? When you're multiplying and you have the same base, what do we do with the indices, ladies and gents? We add them together. So we have 3 to the 1 plus 3m, and that is then further raised to the 1 over n. And then what do we do when you have an index on the inside of the bracket raised to another index on the outside? We multiply them, right? So we'll just rewrite 1 plus 3m as 3m plus 1, and that's going to be multiplied by 1 over n, right? So here when you multiply in fractions, you multiply the numerators together, then you multiply the denominators together. 3m plus 1, then multiply by 1 is just 3m plus 1, and 1 by n is n. So, right, option D here is the correct option. Alright, given that log x to base p is 6, log y to base p is 4, what is the value of log x? Okay, so to find the value of a quotient, you have to subtract. Right, so this would be log to base p of x minus log to base p of y. So that's 6 minus 4, and that's equal to 2. Alright, so once you know your laws of logs, it's an easy application. Alright, cool. Let's go across now. Did I miss one? No, that was 11, right? Okay, cool. Number 12. Okay, so this one I like. I'm going to see if I have time to explain it 2 different ways, right? Okay, so check this, right? You have 3 to the x plus 2, then plus 3 to the x equal to 90. Alright, so what we do here is we kind of extract, we 3x, so to get 3 to the x plus 2, you have to multiply by 3 squared. And then add in 3 to the x, and that's equal to 90. Now what you could do is you could factor out, or factorize, and use 3 to the power x as a common factor. What you'll be left with in the bracket is 3 squared plus 1. That's equal to 90. Now we know 3 squared is 9. And we know 9 plus 1 is equal to 10. So 3 to the power x by 10 is 90. Now, the only thing that could be equal to multiply by 10 to get 90, sorry, is 9. Right, so 3 to the power x has to be equal to 9. We know 9 is equal to 3 squared, and therefore x is equal to 2. Right? Now, another way you can think of it is, look at it, right? We're adding 2 powers of 2, 2 exponents of 2. Right? So your 2 times, or not 2, your powers of 2, right? So 3 to the 1 is 3. 3 to the 2 is 9. 3 to the 3 is 27. 3 to the 4 is 81. And then 3 to the 5 is 243. So we clearly had to stop around here. If you know your stuff, 9 plus 81 is clearly 90. And if you look at it, right, look at the powers. Isn't 4 2 plus 2? Which means that 2 is x, and then x plus 2 is just 4. Alright, so you could also do it that way as well. Which of the following is not an arithmetic sequence? Okay, so again, you have to test each one. And again, not good multiple choice questions. Right? So, long story short is 8. To go from 11 to 2, you have to minus 9. To go from 2 to minus 8, you have to minus 10. To go from minus 8 to minus 19 and minus 11. So that is not a constant decrease. That is a decreasing decrease, technically speaking. So A is the option here. Right? Number 14. Okay, cool. So check this, right? The sum of the first n terms of a geometric series is, okay, so check it. If you want the sum of only one term, which, if you think about it, would have to be the first term. You have 4 to the 1 minus 1. 4 to the power 1 is what? 4. 4 minus 1 is 3. If you want the sum of the first two terms, that's then 4 squared minus 1. 4 squared is 16. 16 minus 1 is 15. But this is the sum of term 1 and term 2. So to go from 3 to 15, you have to add 12. And that 12 is the second term. The third term is 4 cubed minus 1, which is 63. Right? And to go from 15 to 63, you have to add 48. So 48 is the third term. Alright? So right away we know that option 2, the first 3 terms are 3, 12, and 48. Yes. Item 1, the common ratio is minus 1. Nope. To go from 3 to 12, then multiply by 4. And to go from 12 to 40, they also multiply by 4. This is AddMaths May 2024, paper 1. Alright? It's AddMaths. Regular maths is 6:30 this evening. This is the only time that I had to do the AddMaths paper, so I just jumped on and did it. Alright? Okay, cool. Alright, and since we could work on item 3, but since we only have either all 3, which is clearly not an option. So item 1 is out, so we can eliminate A, B, and C. Right? So yeah, we didn't need to, actually no, we should have, yeah, done that thing. Okay, so item 14 is clearly C. Alright? 15. So 15 is a nice one. That's one I've only seen once or twice. Right? So the sum from terms 1 to 2. So the sum of the first 5 terms of minus 1 to the r, then by 3 to the r plus 1. Right? So that you have a what you call it? It's oscillating. Right? Okay. So minus 1 to the 1, then by 3 to the 1 plus 1. Okay. 3 to the 1 plus 1 is 3 to the 2, which is 9. Minus 1 to the 1 is minus 1. Minus 1 by 9 is minus 9. Okay. Minus 1 to the 2. Okay. So you have 3 to the 2 plus 1, which is 3 cubed, that's 27. Minus 1 squared is 1. So that's a positive 1. And 1 by 27 is just 27. Alright, cool. And you have minus 1 cubed. You have 3 to the 3 plus 1. So 3 to the power 4 is 81. 81 by minus 1 is minus 81. Right, so we clearly have an oscillating. So negative, positive, negative, positive. So if we go again, so right away here, we don't have to finish the rest, you know. We could, if you want, just for illustrative purposes, we could do that. But that's the kind of longer way. But I guess it depends on how you define long. 3 to the power 5 is 243, and then minus 1 to the power 4 is just positive 1, so you have 243. And minus 1 to the power 5, you have 3 to the 5 plus 1, which will give us minus 729. So clearly here the negatives are way bigger than the positives. right? So option A and option B are out, and I feel that option C is too small and negative too, right? So option D it clearly is, right? Um, and again, if you know after you get the third term, you can deduce that this is a GP where the common first term is -9 and the common ratio is -3, and you could use your formula, right? The sum of the first 5 terms would be A by r to the n, then -1 over r minus 1. Alright, and you can plug it up and organize. So what's that boy? That's -4 down there. -3 to the 4, 5, that's -244. -4 could go into that, because a minus balances a plus, right? That's what? 6. No. Minus how much I said? 243 minus 244. That's 61 and that's 70. So how we get my -9 now? Alright. No, that's 729. Wow, okay. So yeah, so minus 729 minus 730 minus 730 by -9. 668 something, then divided by -4. Alright. Let's not say we did. I should check that, you know. I should check it. I did buy a calculator this year, and then I lent it to one of my students, and I have not got it back yet. Okay, so let's just check it. So -9 plus 27 minus 81 plus 243 minus 729. No. Minus 5. Yeah, okay. So clearly some of my maths was off or something. So A by r to the n, then -1. Well, r minus 1. Okay, whatever. Moving on. Okay, so let's go. Oh, where was I? Oh, I hate that question. No, it's not a question. I don't like. Because the amount of work, right? Line through these 2 points is parallel to the line with the equation of that. Okay. Yeah, where was I? The value of each. Okay, cool. So if we put this in the form y equal to mx plus c, right? We'll have y is equal to minus 2x plus 10, which makes -2 the gradient, right? Now, of course, as we know, the gradient, right, of a linear function can be given by let's do y2 minus y1. Actually, no, you know what? I know why. Let's do y2 minus y1. So we're gonna have 2 minus 8 all over x2 minus x1. So you're gonna have h minus 4. Right? So that's gonna give us -2 is equal to -6 over h minus 4. And then let's come down. So let's swap out. So -2, sorry. So h minus 4 is equal to -6 over which is +3. And then we have 3 plus 4, which is 7. Alright, so I feel like I'm missing out some 9s in the weekend there. So of course, if anyone not following, let me know. I'll see what I can do. The coordinates of the center of a circle with the, okay, cool. So the generic form for the equation of a circle is x minus a squared plus y minus b squared equal to r squared. Right, that's the first equation of a circle you should learn. It's Pythagoras theorem. Right, which means a, if minus a is -1, it simply means a is equal to 1. And if minus b is equal to +3, b is equal to -3. So 1 and -3, that's like option C to me. Yeah? Alright. Hey, Joanna, there's my cousin. Alright. Line x plus y equal to 1 and those circles intersect at which points what? Okay, cool. So you could again try to solve them simultaneously, but I feel like there was a shortcut here. What was the shortcut again? So if x plus y is equal to 1, that could only be option B. Because if you use anything else like option C or option D, you only get x plus y is not -1. So you don't really have much work to do here. Right? Again, all I did was I just plugged the coordinates up into the linear. Alright, and if it satisfied that one, then you're good to go. Again, little shortcuts here. Alright, so this one, as you can see, whoever got the paper from put a little note that this one was oh, hey, good afternoon, Sharada, how you doing? Yeah, good afternoon. Sharada, how about audio? Like very low, very scratchy, what's going on there? I'm gonna please on that. Actually, I was supposed to check about this. Yeah, they were telling me it was not good quality. Anyhow, triangle OAB has these vertices. These vertices. Okay, so those are the positions. Okay, cool. So given that angle AOB is pi over 2. Now pi over 2 is 90 degrees. Right? Pi over 2 is 90 degrees. So you have a right angle triangle. Right? Which clearly means now, it clearly means that when you have, hold on, what? Given that it was an A, okay, so define A. So these are like in column vector formats, right? So you're kind of, hey Suki, where you going? We're doing add maths, eh? Serenity. Pi today. Okay, that's a nice name. And you figure it out. Pretty cool. Pretty cool. Yeah, so you have these in column vector formats and position vector formats. Alright, so check this, right? Let me do like a little diagram. Alright, so check it. You have 0 there, and you have minus 4 down there. So one of your, what you call it? One of your vertices is clearly going to be like coming here, right? And the angle, so hold on, so that's B. So this is B down here. This is O here. And E. So the only option is 2, 3, 4. But check this, right? If you go to 2, you could draw a hypotenuse, could you not? Yeah, you could. If you go to 3, you could also draw a hypotenuse, could you not? If you go to 4, you could draw a hypotenuse. If you go to 6, you could also draw a hypotenuse. So all of these here, right, they're all correct. Right? They clearly didn't put something in the question they thought they did, or they thought that was understood to narrow on the option they wanted to choose, which I don't know which one it is. Anyhow, so yeah, so this question here clearly has a C. Okay, anyhow, let's go again. Right, the vector A is given as 5i plus 12j, a unit vector parallel to this. Okay, so to find a unit vector parallel to it, what we have to do first of all is find the magnitude of the vector, which is the square root of the sum of the coefficients squared, which again is Pythagoras theorem. Alright, so if you know your Pythagorean triples, this is just the root of 13. Sorry, not the root of 13, my bad. Yeah, just 13 squared, so which is just equal to 13. So it's just this vector over 13, or 1 over 13 by that vector, which is option C. Alright, easy things. If you know your book, right? Sharada. Sharada, sorry, I now see your question. 6:30 this evening. 6:30, yeah. This is the only slot I had to do the add math paper. I have a 4 to 6 regular math, and I have to go for my son from daycare between, and I finish this in a 4 o'clock class. So yeah. Okay, the position vector of the point P relative to the origin is that, and the position vector of Q is that. Okay, cool. Which are true? Okay, so if they are parallel, then they are what you call scalar multiples. It means that if we factorize, if we pull like a minus 2 here, you're going to get a positive 2i minus a 5j. But that doesn't match to this. As a matter of fact, the coefficients switch, which leads me to believe that they're going to be perpendicular. Like if you multiply 5 by minus 4, what do we get? Minus 20. And 2 by 10 is 20. Minus 20 plus 20 is 0. And when the dot product of two vectors is equal to 0, the angle between them is 90, which means that they are perpendicular. Twin, yeah, that's correct. Add math. Alright, 22 now. And with that, we'll be about halfway through the paper. The easier half, right? Cos 2x. Okay, so if you expand cos 2x, you get cos x by cos x minus sin x by sin x. Now, of course, cos by cos is cos squared, sin by sin is sin squared, and as we know, cos squared is 1 minus sin squared. So we have 1 minus sin squared x, then minus sin squared x, which gives us 1 minus 2 sin squared x. So sin x is just s. Cool. Alright, so that is the third page. Again, so that's basically the first half of the paper done there. right? So we did it in about a little more than half an hour. That's not bad, right? You have about 2 minutes a question because it's 45 questions in 90 minutes, right? Yeah. Yeah, sure. I hope you heard me. That's still a senior question. I didn't see anything after that. Okay, if the area of the semicircle is 32 pi, what is the length of the arc connecting points A and B? This is interesting. Okay, so arc length, right, which I call S, is equal to R by theta, right? The area of the arc is equal to half R squared theta. Now R squared is what? R by R. So you could have a half R by R theta, which we know is just S. Right? And we know S is what? 30. We do know S, right? But we know that the area is 32 pi. Right? So 32 pi is equal to, so I guess we can put R over 2. R? Is R over 2? Yeah. By S? Hold on. A half R squared. If the area is 32 pi, what is the length of, hold on. Go after that. So a half R squared theta is just the area of the sector. Right? So that's what I did with a half R squared by theta. A half R by R. So a half R squared by theta is 32 pi and a half S. So if we divide that by, okay, cool. So when we divide, we're going to have 32 pi divided by R over 2 equal to S. So when we invert and multiply, right, so we're going to have 64 pi over R. Okay, alright, so you know what I didn't do? I didn't solve for R. Alright, so let's backtrack. The area of a sector is a half R squared theta. It's a semicircle. What's the angle in a semicircle? 180. And that's equal to pi radians, right? So 32 pi, which is the area given to us, is a half by R squared by pi. So if we knock out pi from both sides and then multiply by 2 to get rid of the half, you get that 64 is equal to R squared, which means that R is equal to 8. Okay, cool. So we're gonna have what you call it? So if R is 8 now, right? We can replace this, right? Yeah. So let's put that over 4, over 8. Sorry, over 8. My bad. Right. So 2 into 8 is 4, and then 4 into 32 is 8 pi. So 8 pi is the length of the arc. Right. Okay. Yeah. So you see, sometimes I could go down a wrong route as well. Very good, Chantal. Alright, good job. Item 25 this is cos x. Cos x starts at 1, goes to 0, bottoms out at -1. Oh no, this is not cos x, because it would have been 2 pi. Yeah, sorry. See why it's important to read very carefully here. This would have been pi here, and then this would have been 2 pi here if it was cos x. But since it's not, that's a full cycle of sine half the time, so that's cos 2x. Yeah, that's B. Yeah, you have to kind of know your diagrams. I can't go into details right now. Yes, I didn't know them or you don't know them. Right? I think I have a live. Right? 26. 26 is a repeat, but I don't like it because, okay, whatever. Okay, if you multiply these two things together, what are we gonna get? We're gonna get 1 minus cos squared, right? Which we know turns into sine squared. But then you have to multiply each numerator by the opposite denominator. So sine x by 1 plus cos x. Sine x by 1 is just sine x. Sine x by cos x simply gives us sine x cos x. Cool. Plus, then sine x by 1 minus cos x is sine x minus sine x cos x. So this cancels with that, and we're going to be left with 2 sine x. And then 1 minus cos squared in your denominator is sine squared. And the sign in the numerator will cancel with the sign in the denominator, giving us 2 sin x. Alright, cool. Zayden, May 2024, this is last year's paper 1. If sine 90 minus x equals to cos x, the value of x is, well, anything between 0 and 90. So yeah, all of them, all of them are correct. There was another question where the 35 was the answer. So yeah, I think they wanted to switch this. It was, what was it? Was it 16 minus x or something? I don't know. Well, right, this one here, if you put a and a b, a and a b, right? So sine a cos b minus cos a sine b. So that's a sine a minus b. And then that's 50 minus 40, which is 10. Right, so that's sine 10. When I was browsing through the paper, sorry, yeah, what year? 2024, guys. Sorry, okay, let me just put the comment and put it. 2024. Tanya, how you doing? Pin, right, okay, cool. In my calculator, I trust. Yeah, for sure. Use your tools, guys, use your tools at your disposal, right? Don't be afraid to use them, but make sure you know how to use them properly. Alright, cool. Where was I? Okay, let's zoom in here so we can see. Okay, so we have a plain old triangle. The sum of the interior angles is 180. So if you have 100 and you have 60, this has to be 20. And to convert that, right, so the first thing we'll do is we'll divide by 180 and then multiply by 5. So knock off that, and 2 into 18 goes 9 times. So today we have pi over 9. Sorry, Malia. Hi, Sid. Do you think there were any errors in the paper 2? The AdMath paper 2? I did pieces of it, you know. I can't give you a proper opinion because I didn't do the whole thing. Kefira, calculators aren't allowed in math paper 1, but this is AdMath. So you are allowed to use calculators. Yeah, Kidia, that's correct. But Malia, I can't say 100% with 100% surety because I didn't do the whole paper. I just did pieces and posted it on TikTok. The pieces I did, I don't think there were any errors in them. Let me know which question you think that Kefira is Kefira? Yeah, no, not Kefira, sorry, Malia, my bad. Yeah, okay, cool. Number 30, sine of pi over 2 minus x and cos of x plus pi. Okay, so that's 90 degrees, right? Okay, so the expansion for sine pi, so I'm not going to use pi, I'm just going to use 90, right? So that's sine 90 cos x minus cos 90 by sine x plus, right, so then that's cos x by cos 90 minus sine x by sine 90. Now, cos of 90 is 0, so this is going to cancel, this is going to cancel. Sine 90 is 1. So you're going to be left with cos x minus sin x, which is option C. Cool. Alright, given that y is equal to that, then dy, okay, so we're into calculus, not derivatives. Right, so we'll rewrite the function as 5 minus x to the power of a half. Right, then the derivative of y with respect to x. So the algorithm is multiply the index to the front, decrease the index by 1, and multiply by the derivative of inside the bracket. Alright, so we're going to have a half multiplied by 5 minus x to the half, then by minus 1. So yeah, you could have minus 1 all over 2 by the root, sorry, just straighten that line, by the root of 5 minus x, which I believe should be option D. Alright. Hey Paige, how you doing? Coming later? Right, so guys, question, I cool, it's a little sleepy, but what's new? Alright, so this is the one my question, my question. My friend, who again, his degree is maths, he has been a math and pure math teacher for 25 So I refer to him whenever I have trouble with maths and maths, right? Which I do from time to time, you know, or when I have questions about the syllabus or how the marking goes or interesting things about CX. Anyhow, so he said this one has no solution. So it says, at the 10-meter stopping point on a runway, an airplane is stationary for takeoff. If the airplane then travels 120 meters from this point in 4 seconds, what is its speed at the point of takeoff? So I think that they think the question is vague, and I think the simple thing to do is to take 120 and divide by 4, which will give you 30 meters per second, right? But I have to ask him why he thinks this question has no solution. So you have airplane at that, right? Okay, then you travel 100. So what is this? I should say average speed. No, average speed is total distance traveled, total time taken. Right? What was the average speed? But clearly we know it's for the aircraft to be. I mean, I don't know anything about. I mean, my dad was the air traffic controller, but to me, the aircraft would continue to accelerate until it hits the velocity at which the wind resistance will allow it to take off. Right? So again, I have a suspicion about this question because my friend said so. So we'll put a little thing there. All right, just in case. All right, 33. The gradient function dy dx of this curve is okay. Cool. So we have the derivative of a sine of an expression, right? So when we find the derivative of this function dy dx, right? First things first, we have to find the derivative of sine, which is cosine. So that's just cosine of 2x squared plus 1. And we have to multiply, like we did just now, by the derivative of inside of the bracket. So yes, average speed is total distance over total time taken. Yeah, so I would agree that to me seems like an answer, but again, I cannot default to his wisdom because, again, he's kind of my superior in this particular matter, right? Yeah, and the derivative inside of there is just 4x. So 4x by cos of 2x plus 1. What year is this? 2024, May 2024, maths paper 1. 34, the point 1, 1 lies on the curve y equal to 3x minus 2 over 2x minus 1. The gradient of the tangent at point P is, okay, cool. This is clearly a quotient rule, right? So, oops, why is my pen right? So, dy dx, so that's going to be equal to, right, v by du dx minus u by dv dx all over v squared. Right, so that's 2x minus 1. So du dx would just be 3 minus u, which is 3x minus 2 by dv dx all over v squared. Okay, cool. So you can multiply that 3, you're going to get 6x minus 3. And then you're also going to get 6x minus 4. But that, you have a minus in front of that, right? So you're going to have to minus 6x but plus 4. And that's all, oh sorry, hold on, my wife calling. Hello? That sounds familiar. But all I remember from last week was that she couldn't make it Saturday. It's possible. It's quite possible, and I forgot. Because I recall discussing something else with her. But I can't tell it specifically. I know we were talking about a few different things. Because we were also talking about like what the schedule for summer would be like. Yeah, okay. Alright, I'll give her the benefit of the doubt this time. Yeah, okay. Right. Okay, sorry. Just had a little miscommunication with the babysitter. Wasn't. Anyhow, we had to stop that. So 2 by 1 is 2. 2 minus 1 is 1. 1 squared is 1. One second, I got it. Yeah, sure. Alright, so the curve C has the equation y equal to f of x. C has a stationary point at that. If f of x, if f double prime was that, then minus, okay, so double prime gives us a nature the stationary point. So what we have to do is substitute the x value, the x coordinate of that point, into the second derivative, right? So what we're going to be doing is find f double prime, or d2y dx2 of, well, minus 1 in this case, sorry, minus 1. Right, so that's going to be 6 over minus 1 to the 4th power plus 2. So minus 1 to an even power is 1. 6 over 1 is 6, and 6 plus 2 is 8, which is positive, which means you have a minimum turning point. Alright, cool. Item 36 refers to the following graph, which shows the journey of a boy, where time is given in seconds and velocity in meters per second. Time is given seconds. Okay. During the journey, there is a stage where the boy accelerates. Right? The value of acceleration is, so that is this piece on the graph here. Okay? So acceleration is basically the gradient of the velocity time graph. Right? So acceleration is a change in velocity divided by the change in time. So velocity changed from 10 to 20, so that's an increase of 10, right? And time went from 4 to 8, so that's an increase of 4 seconds, so that's 2.5 meters per second squared. Alright. Okay guys, we're in the end game here. Alright, the less than 10 questions to go. Yeah, I should finish anytime I need to finish it. Alright, let's take a look at if C is a constant and the integral of, okay, so the integral, so it's basically the chain rule of integration, as I have to call it, only for linear functions, guys. Right? If you have like a power squared or minus something inside, it doesn't work. Alright, so what do? We increase the index by 1. We divide by the new index and by the derivative of the core. So that's 2x minus 5 to the 4 over 8, then plus C. Yeah, that's option C, right? If the integral between 4 and 1 of f of x is 6. Right, so here we have some little tricks we could apply. The integral of between the C limits of 4 times f of x is 4 times the integral. Yeah, I tried to get my integral signs nice and fancy, right? And you can add 5 after that, right? Okay, cool. So 4 times that is basically 4 times 6, which is 24. 24 plus 5 is 29. Cool. 39. Right, if C is a constant, then the integral, okay, so the integral of sine is minus cos. The integral of cosine is just sine. And if you have a coefficient in front of the function, it just goes along for the right. So 2 sine x minus cos x. Sorry, yes, plus C. That's correct. Oh, there was a question below that. Wow, almost forgot. Okay, the region R is enclosed by the x-axis of that curve, y equal to minus x squared plus 2, and the lines x equal to 0. Okay, cool. So they want the area. Okay, so we have to do a full blown integration, right? So the integral between 1 and 0 of minus x squared plus 2 dx. Alright, so when we integrate, what do? We increase the index by 1, divide by said new index. Alright, now you don't have to put the constant in. That's how I was trained, so I put it in. but it cancels, right? Because when you are integrating with limits, you're going to subtract. Right, and then you could also ignore the zero because when you sub zero inside of there, it's just going to cancel everything. So basically what you could consider is just, you're going to have the negative of 1 cubed plus 2 by 1, over 3. 1, right? So 1 cubed is 1, and so you have a minus 1/3 plus 2, which is 1 2/3, and 1 2/3 is 5/3. Cool. Alright. Sorry. There are 108 cards in a deck of Uno playing cards. Of these, four are wild, 4 are wild draw 4, and each of the 4 colors is represented by 25 cards. And each of the 4 colors is represented by 25 cards. Okay, right, that's 100. 4 by 25 is 100. 4 wild draw 4, so that's 8. Okay, if a player needs to select one card, what is the probability of not drawing a wild draw 4? Okay. There are 4 wild draw 4s. You have 108 cards in the deck. So you have 104 over 108, which is 26 over 27. Okay, cool. Wasn't bad. A lot of oh, this still is a 42. Sorry. Hold on. Sorry. Let's do that. Yeah. Let's just scroll down. One advantage of using a box and whisker plot is variance can be identified, not that I know of. All data values, no. The mean, no. The spread can be, yeah, because you have the highest and the lowest value. So yeah, option D. Alright, last 3 questions. Items 43 and 44 will be funded. Okay, cool. So there are 120 students in a school's music club. The Venn diagram shows the probabilities that a randomly selected student plays the piano or guitar. What is the value of X? So the X is people on the outside of both of those sets, which means people who play neither. So if we add up all of these, alright, so that's going to give us 0.9, right? So 1 minus 0.9 is 0.1. 0. Oh, there you go. What is the value of X? So there's 0.1. Okay. Alright. What is the probability of n given g? Right, so the probability of n given g is equal to the probability of n intersect g, then divided by the probability of g. Right, so that's this divided by the sum of those two things. 0.35 over 0.35 plus 0.15, which is up as 0.5, so you have 0.35 over 0.5, which is 35 over, what you call it, 50, which is 0.7, 70%. Okay, and the last question, right, item 45 refers to the following diagram. So the probability of A is a third, and then it's 2/5 or 3/5 to A given A and B given A respectively. The tree diagram shows the probability of events A and B occurring based on the diagram. The value of the probability of A given that B has already occurred is 4. Right, and there you have it. That's the solution to the May 2024 Add Math Paper 1. Alright guys, so it took just about less than an hour to do it. What time is it? 58? Alright, cool. So let's just call it a nice hour. Alright guys, so I think I have a couple more Add Math lives multiples on my YouTube channel. You could take a look. If it's not it, DM me on a platform and let me know. See if I could open up 1 or 2 more. I can open up all. Alright, I'd have saved something for, my clients. Anyhow guys, so good luck tomorrow. Keep your head on, practice proper exam technique, don't get flustered, do what you can do. And as you saw, this paper had 2 errors. So it's quite possible an error exists in the paper, but don't default to that all the time. Right? And if you don't know, guess, you have a 25% chance of being right. If you could eliminate 1 option, you have 33%. If you eliminate 2 options, you have 50%. Alright, anyhow guys, I am back on later. Well, that's what I'm doing here, Suki. I'll leave you on my brain for now. So you could learn from it and go in the exam and use your own. Alright, yeah guys, so I will be on about half 6, so in about 4 more hours before the math paper. Today is Jan 2022. I had to make sure I had a paper prep.